Hello everyone. I'm a designer. And I see design as the first signal of human intention. What do we intend? Designers solve problems, but they also create beauty. Sometimes you do it at the same time, sometimes it's separate. But when I look at design today, I see a lot of things that are real design problems. Because we can not only provide solutions, we can design problems. And so I would like to talk about nature because nature doesn't seem to have a design problem. People do. When I was a child and I would go to the beach, if I picked up pebbles or seashells, I would say, aren't they beautiful? All of them were. Every pebble, I couldn't find ugly anywhere. And yet, if I go to a gravel quarry and I find sharp rocks, I say, ooh, they don't look like fun to walk on. They don't look like fun to collect. So the idea that nature has this beauty inherent in it is really something important for designers. And as we look at the whole world of design, we realize, as Carl Sagan said, if you want to bake a pie from scratch, first you have to create the universe. So if we want to design things that are fresh and wonderful, first we have to look at the planet we're on and ask, is this what we really want? Is this what the planet needs? Is this what people really need, writ large? So very small things, very big things. So people talk about thinking globally and acting locally, and I think that's really important. But I also think we should act, in a way that's molecular. So let's think galactically and act molecularly. So the scale is really huge. But it's all one thing. Nature doesn't have a design problem. People do. So when I was a lot younger, I decided that I'd become an architect. And I wanted to design buildings like trees. Here I am in college, and I'd see a fire burning in our fireplace. We were in New Hampshire. And I would look at it and think, wait a minute, that's entropy, everything going to chaos, not to return. We learned about that in physics. And then I thought, well, what would the opposite of the entropy be? What would order out of chaos look like? So I realized it really wasn't in the physics library, per se. It was in the biology library. It was the log itself, was order out of solar flux that was coming from the sun, entropy, and it was carbon from the atmosphere, and it was rocks and minerals and water on the Earth's surface, and it all came together to form life. And that was order out of all that, the order of living things. And that becomes humus in the soil version, it becomes kelp in the ocean and so on, and algae, but you think about that, it's really order out of chaos, and we're part of it. The word human is derived from the same root as humus, so we're the soil people. So then I thought, well, if I'm going to be an architect, I'm going to design buildings like trees. Why not? Nature does it. What if we did it? So what if I could make buildings that could actually accrue energy from the sun and give it to the neighbors? What if a building could purify water? Provide habitat for hundreds of species, change colors with the seasons, and so on. Wouldn't that be amazing? So that's what I was thinking about as a young designer, wondering about that. And then when I went to Yale Architecture School, 1973, we had the energy crisis. So all of a sudden, everybody's like starting to worry, as we can imagine. This is a real serious concern economically and physically. So all of a sudden, I thought, well, now's the time to design a building that's powered by the sun, obviously. So I started working on a solar-powered house for Ireland, since my ancestors had come from there. I thought, I'll go to Ireland and build a solar house experiment. So that's what I did. And it was hard. When you're young and you've never built before and you're learning and you've got solar energy you want to do. I had some help from NASA, and other architects, and it was really quite something. But I had a broken back, and I am learning how to lay block and bend metal and lay slates on a roof, and it was really an amazing experience. But that's what you do. And I made some mistakes, but I remember Esther Dyson with her famous quote, always make new mistakes. So this is what we do when we innovate. And failure is not failure unless you quit. So persistence and grit is essential to this. You just hang on, keep going until you get there. And if you can't, well, fine, you tried. So that's what I was doing. And it was really quite a wonderful experience. So then when I was at Yale, working on this design, a very famous architect came, was teaching there. And he came over to me and he said, what are you doing? And I said, I'm designing a solar-powered house for Ireland. And he goes, young man, solar energy has nothing to do with architecture. He did very famous, fancy buildings. And it was like, really? I thought Vitruvius said all buildings have to be located in the sunshine to make them livable and beneficial and warm up in the morning and watch out for hot sun in the afternoon and so on and so forth. And it was like, humph. He walked off. And I thought, I got to keep going because there's something I have to learn here. So then I decided I would work this way as well as try and design beautiful buildings. And then in 1989, years later, when I was in my own practice, I won an international competition for a skyscraper in Poland right before the fall of the communist government. And I designed this tower and it won the competition. And I said, but you have to plant 10 square miles of trees to go with this building. 5 square miles of trees to offset the coal burning that went into making the building, and 5 square miles to offset the operations of the building, which would be powered by coal-fired plants. And everybody said, this is odd. It ended up in the Wall Street Journal. And what was exciting for me was just the idea is so important, and yet when we priced it, then it was less than 10% of the advertising budget. Can you imagine? So all of a sudden we realized we're still talking about that here. This year, we're talking about planting trees again, but this is 33 years ago. So it was clear, this is a way to think, and let's figure out how to get this stuff done. So after that, I won a competition for a daycare center in Germany, in Frankfurt. And I thought, I'll design a daycare center that can be operated by children. And they can move shutters and open windows, and they can manage the sun and the temperatures and the humidity and all the elements themselves. Very simple windows, shutters, these are not complicated things. And they can be fun, cranks, and they can play with it. And the engineers came, and the teachers and I were meeting, and they said, you can't have a building operated by children. I said, well, that's okay. We have regular systems, but we're going to make it so they could open windows and move shutters and run the building. And the engineer said, no, no, no. Children shouldn't be operating a building. And the teacher said, excuse me, the hardest thing we have to do with these kids is find things for them to do. So if they wake up in the morning, and they can wake the building up in the morning, and they can put the building to bed at night, and they can watch out for hot sun in the summer and shade and let it in the winter to warm them up. This is a great thing for these children to understand where they are. We can have a solar-powered laundry for the parents while they're waiting for the kids. We can have gardening on the roof. They can grow food. One thing after another. A building that creates order out of chaos. What fun. So after that, I went and started thinking this way for all of our projects. And so I got to design a space station on Earth with NASA, if you can imagine. A building renewably powered that can produce more than it needs for the neighbors. It has solar collectors on it. It's connected to the ground and all kinds of things like that. Recently, we had a building opening in Bogota, which is a university building where the students will be studying the circular economy and cradle to cradle. And there are 18,000 students already. This is a very exciting time for so many people who want to go into business and do it this way. So this is a building, that's like a festival. When you see it, it's like gift wrapped, and it's shaded, and it uses the energy of the day actually draws the air through the windows. Such a beautiful climate through filters. So it's quiet, but it has fresh air everywhere and filtered, and it's powered by the sun. So buildings like trees. The idea, though, of looking at materials became fundamental too, because in designing that daycare center, I saw that the children were all had their mouths on everything. So I wondered what was in those materials. And so I met with an ecological toxicologist 2 years later, Michael Braungart, who had been working in Greenpeace and had developed some phenomenal ways of thinking about biological materials, technical materials, and safe and healthy. And so together we created Cradle to Cradle and wrote the book, Cradle to Cradle, Remaking the Way We Make Things. And this idea of seeing things as ready to go back to biology or ready to go back to technology in cycles became fundamental to Cradle to Cradle, and then evolved into also the circular economy, because we're looking at the idea of eliminating the concept of waste. So first, safe and healthy in biological and technical systems, products of consumption, products as a service. Then that can move to the circular economy, where we use things over and over again because they're designed to be used over and over again. So we design not for the end of life, we design for the end of use, which means then you design for next use. And once you do that, you're in the circular economy. So we have the circular economy, and I had the privilege of representing the United States in the China-US Center for Sustainable Development in the 90s with my co-chair in China, Madame Deng Nan, Deng Xiaoping's daughter. And we were looking at Cradle to Cradle, the circular economy, and the search for ecological civilization, you can imagine. So that has manifested, as we see, in various ways. And the Chinese government had the 12th five-year plan called Circular Economy, and the 13th called Implement Circular Economy. And so that's been quite exciting to watch. It's been taken up by the World Economic Forum. It was taken up by groups in Europe, like the Ellen MacArthur Foundation. It's taken up by the EU as a strategy. It's really quite wonderful. So the circular economy. But then I was asked to look at carbon, because I had written an article on this, thinking about it. I know I was doing renewable powered buildings, and I knew that I was designing at this molecular level. But the idea of coming together and saying, what's the role of carbon in the circular economy? And you realize that carbon is both a material and a fuel. Amazing. So because of that, we have carbon in the biological cycles, which is cycling with the atmosphere, on a 25-year cycle roughly. Trees fall, die, release carbon, absorb carbon, so on, and accrue as soil and in marine verdure and so on. And then we have the technical materials, but they're powered by carbon from the ground right to the atmosphere because we burn it. So all of a sudden we started to look and say, there's one thing in a circular economy to reuse everything, but there's another thing which we want to remove, and that turns out to be carbon in the atmosphere. So let's look at carbon as a living thing, and a durable thing, and a fugitive thing. And let's put it back into the circular economy and imagine that we have a regenerative biosphere. It's regenerating and taking carbon back and using it to make more life. But in the technosphere, we need to do massive energy efficiency to stop releasing the existing carbon in the system. We have to do massive renewable power now that it's cost effective. It's quite astonishing when you see what's possible. We have to encourage nature-based solutions for carbon capture, like plant mangroves, do regenerative agriculture, all those things. But we also have to look at the technological world and figure out how we're going to recycle things as durable carbon, make new materials using the carbon so we can make it durable on Earth. We're going to be wanting to sequester carbon, put some of it back where we got it, and other things like that. So it's time for a technological moment where we actually bring our technology to this question in a new way. And for a lot of people, it's tough to imagine mechanical capture of carbon from the atmosphere. But it's an essential thing for us to think about, an essential thing for us to perhaps innovate into. And as recently as a few weeks ago, Elon Musk announced a $100 million X Prize for carbon capture at the scale that's going to be needed to really imagine we can start to do this. So our innovators are thinking this way. Will we have it right away? No. Will we have to make test rockets that go up and come down? Yep. Well, will we have to fail to succeed? Probably. But this is something we can all do together, and we must do together, is to take on the climate issue, because nature doesn't have a design problem. People do. And people may have created the problem. And so if the problem is created by people and our designs, we need a new design. And when we say it's not our plan to heat up the planet this way and dislocate so many people, if it's not our plan, it's become our de facto plan. It's the thing that's happening because we have no other plan. So all I can say as a designer, it's time for a new plan. And I guess that if we follow the laws of nature, the odds of it being beautiful are a lot better. Thank you.